Hello, ladies and gentlemen, and welcome back. Root Beer here with question number 24 on the 2000 Fermat paper, which involves a nice little system of equations. So, for the system of equations x squared plus x squared y squared plus x squared y to the fourth equals 525, and x plus xy plus xy squared equals 35, the sum of the real y values that satisfy the equations is... Okay. Alright, so, for it to be a system of equations, if I have a pair of x and y that satisfy this one, then they've got to satisfy this one. That's what it means to solve a system of equations. You have to solve both the equations simultaneously. So, let's write these guys down and see where we can go. First one here is, what is it, x squared plus x squared y squared plus x squared y to the fourth is 525. And I think our next one is, I'm spacing them out because I think I already have a plan. Xy squared equals 35. So I'm pretty sure, but let's just double check, 525 divided by 35 is 15. So I do have a nice integer division there. Then again, they're talking about real values of y, so I assume real values of x and y are fair game, so it doesn't really matter if 35 divides 525. So, first thing I'm going to do is, I notice I can take out this common factor here. 1 plus y squared plus y to the fourth. And I can take out a common factor of x here. Notice that the terms are very similar, and each term in the expression here is squared to give the expression in the top equation. I think that's designed to trip people up who don't understand that squares do not distribute over addition, which is something that plagues university students still. So if it happens to you, that's okay. You're not alone, and it's going to happen. It happens to a lot of people for a very long time, longer than I think it should. Anyway, so my plan is this. I'm pretty sure y can't be 0. Or sorry, y can't be 1. If it was, then we'd have x squared times 3 is 525, and x times 3 is 35. So let's just check. 35 divided by 3. That should be x. Now if I square that, I do not get a third of 525. I get a third of 408.3 repeating. Okay, so what can we do here? Well, if I know that y can't be 1, then what I can do, I can keep this x squared here, and, well, that's a good question. Can y be, no, y can't be negative 1 either. Alright, anyway, what I can do is I can say y to the power of 6 minus 1 over y squared minus 1. So if you perform this long division, you will get 1 plus y squared plus y to the fourth. And I can change this one into x times y cubed minus 1 over y minus 1. So this would be a problem if I were dividing by 1, but neither y equals 1 or y equals negative 1 will work. If y is negative 1, this is still 3, and this one down here becomes 1. So 35 squared times 3, it's certainly well beyond 525. So y is not 1 and y is not negative 1. This might come up later, but I'm pretty sure we're good right now. Now, y squared minus 1, this is a difference of squares. And a difference of squares can always be written as the sum of the two squares times the difference of the numbers that we're squaring. So, x squared y to the 6 minus 1 over y minus 1, y squared minus 1 is the same as x squared y to the 6 minus 1 over y minus 1 y plus 1. What's more, y to the 6 minus 1 is also a difference of squares. This is y cubed squared. Y cubed squared minus 1 squared. So it's going to be y cubed minus 1, or plus 1, times y cubed minus 1. So it's x squared. Y cubed minus 1 over y minus 1. Y cubed plus 1 over y plus 1. Hey, isn't that the expression we have right here? In fact, it is. So if I take out one of these x's, and the y cubed plus 1 and the y plus 1, I get y cubed minus 1 over y minus 1, which is just 35. Okay. So 35. How does that come into it? Well, that means when we divide 525 by 35, because this whole expression is equal to 525, that means that 525 divided by 35, which is 15, is the same as x y cubed plus 1 over y plus 1. Okay. Now y cubed plus 1 over y plus 1, I think there's a way to get rid of that as well. I think that turns into something. I think y cubed plus 1 is y plus 1. So if I wanted this to, it would need to be times y squared. Okay, and then to get this one out here, we'd have to have a plus 1, and then what would we need in the middle? Well, I'd have a 1 times y squared, so I'd need to get rid of that, so I need a minus y. So y times minus 1 gets rid of 1 times y squared. That's why there's no y squareds in the product. And then 1 times minus 1 minus y cancels out with 1 times y, and that's why there's no y's in the product. Okay. So that means 15 is equal to x times y squared minus y plus 1. All right. I think because of how nicely everything's behaving, we've got to be on the right track. So let's look at the equation with 35 in it. So that was x plus xy plus xy squared equals 35. And now we know that x minus xy plus xy squared is equal to 15. Okay. Is that particularly helpful? And could we have seen that already? I am actually just noting how easily that came about. Was there an easy way just to do that? Yeah, there probably was. Oh well. Sometimes I take the longer route around. That doesn't really mean anything. So what I could do is I could subtract the two, actually. Get rid of these x's and these xy squareds. So let's subtract the two. So I get 0. I get plus 2xy, because negative negative makes a positive, plus 0 is equal to 20. And that tells me that xy is going to be 10. Fantastic. I can put the xy to work. I can say, well, you can put it in here, and you can put it in here, and I'll get what x plus y is. So why don't we do that? So then x plus 10 plus y times 10 is equal to 35. Okay. Not the best, not the greatest thing I was hoping for, but that's okay. So then 10y plus x is going to be the same as 25. I don't think that has particularly helped, but, you know, maybe, well, now I've got, I know that y is going to be 10 divided by x, and I have a 10y right here, so, actually I should probably rearrange this. X is going to be 10 divided by y. Okay, and so I can substitute in 10y plus 10 over y is equal to 25, and now I will get a single quadratic in terms of y. Okay, y clearly isn't going to be 0, so I think we're all set there. So 10y squared plus 10 minus 25y equals 0, or let's write that in the more traditional way, 10y squared minus 25y plus 10 is equal to 0. Now, I could use the quadratic formula, and I could definitely figure out the possible values of y that solve this, and then therefore solve the rest of this, but I don't need to. Because if I have a quadratic and I know its roots are a and b, so this is a handy little trick sometimes. If I know the roots are a and b, then I can factor it as x minus a times x minus b. But when I write it out, I will get x squared minus a plus b x plus ab. So all I need to do is get this in the form where we just have a coefficient of 1 in the front, and I will know the solutions for a and b. Okay, so y squared minus 25 over 10 y plus 1 equals 0. So the solutions are going to be 25 over 10. That's the little sum of y's. So I'm pretty sure that that's the case. Let's just double check. Is that one of the possible answers? Oh, 25 over 10 simplifies, doesn't it? 5 over 2. And I think I just saw that that was E. So we're going to go ahead and say that the answer is E. Alright, now if I were not confident about this, if I didn't want to use the rule, I can still use the quadratic formula. So y is going to be negative b plus or minus the square root of, I don't really care what, but b squared minus 4ac all over 2a. But these two guys, this plus and minus, this is going to cancel itself out, and I'm going to get basically 2 copies of 25 over 20, which is going to be 25 over 10. Again, if you wanted to actually compute this out and figure out exactly what y values there were, by all means, go right ahead. But I'd say we've done it now 2 ways, where 25 over 10, which is just 5 over 2. So I liked that. It was a nice little system of equations, manipulation style question. I wish I'd seen the way to get 15 a little quicker, but hey, nobody's perfect. So we just have one more question to go, question 25, and we'll take a look at that in the very next video. So thank you guys so much for watching, and as always, I'll see you next time.